On a previous presentation today, it was stated many times how important it is to have a good local validation. And today I will focus on what to do if this validation fails, why it fails, and how to fix it, how to achieve the reliable local cross-validation strategy. A few words about myself. I have background in software engineering, and couple last years I was participating in a number of Kaggle competitions. I had a lot of fun, and on the first competition I tried, it was about the classification of images. It was necessary to find what kind of fish present of images from fishing boats, and I built a model, I started training, I selected randomly 20% of samples for my validation set, and it's quite common, as you see. The training loss drops, validation loss also drops, levels up, and I was waiting until it goes to minimum, and once it started growing, I stopped and prepared submit. And as you can guess, at least from my presentation, it was disaster. It was very close to the very bottom. It was way worse than sample submission on just predicting mean value. And it's expected when model overfits and we're using the categorical cross entropy. So it penalizes very heavily for wrong but overly confident prediction. I tried to do submission, which was half of the train epochs, and it scored much better. But the problem is why my validation doesn't show this. I understand why it's unfits and so on, but it's actually also quite common in other competitions. Probably every second competition on forum, I can see that for many people, the local validation display much better scores than Leaderboard, and sometimes the difference is very significant. So, in this particular case, it was caused by it's actually data in data set. It was captured from camera on the boat, and very often when fish is caught, there was some video, so there was multiple frames of the same video, very similar frames and slightly different poses, people taking this fish and so on. But it means that for almost every image we have in validation set, we have a couple of images in training set which are very similar. So in this case, model can overfit not even to the fish. It can overfit to people around, to the boat, to anything. And validation just fails to show this. And once this is known, it's also very clear how to fix this problem. So it's necessary to make sure that if we have multiple related images, we want all of them to be either in training set or in validation set. And we're using multiple faults. We want all the related images to be in this single fault. So in this particular case, since images are very similar, I just downscale them to very low resolution, like 16 by 6 and 32 by 32, and used distance between images, just pixel distance for clustering, and it worked very well. So I created a very large number of clusters, a few hundred clusters, and distributed them to faults, trying to keep the distribution to match the overall trained dataset distribution. And in this case, it's very drastic change. So this model doesn't perform any better, but at least now we see how it performs. We can select, it probably even performs slightly worse because now I see only 3/4 of data set, realistically. But at least we can start tuning hyperparameters. We can apply more augmentation to or any different techniques, we can select the point where to stop. And it's not only these benefits. Now we have 4 models. For example, if we're building 4 faults, which train on much more different data sets. So we have much more diversity between our models. It's also, I try to have a look at prediction of each fault, and I found that in most cases, in this case, if model is very confident but wrong, it's actually model was right. And in this data set, there was very noisy annotations. So it helped in like maybe 70–90% of those very confident but wrong prediction. I just replace them after visual inspection, and I have another improvement in performance. So by doing this better false split, I now can very cheaply fix my data set. I don't want to check all the samples. I can check like 5% samples and fix the the biggest problems and have much better performance. It's another benefit that the model trained on those different faults, they do ensemble much better because they're more diverse. And especially in the case if we have log loss or categorical cross entropy for multiple labels case, it's much less likely than all 4 models would have the same wrong prediction. So we reduce the case which penalize the heaviest by our metric. And it's also very important if you are going to do any second level stacking or performance. So if your prediction are too optimistic out of fault, it means you have leakage between faults and you cannot expect second level model to perform well. It's also quite useful to track like difference spread between the training loss and validation loss. And like in this case, it makes sense. Because usually if you see that it almost level up, but training loss continue to drop quickly, it's probably not very useful to continue. But in this case, you would see this. Otherwise, there is no point to looking on this side. Another benefit of having those diverse models is probably slightly opposite to pseudo-labeling on what you want to focus, but the most useful samples in training data set is samples where model reach very close to the decision boundaries when model is not confident. And if you have very large set of unlabeled data that you could very efficiently select which one to label. It could be too expensive, not practical to label all of them, but you could achieve the same performance with like 10% of your extra data set. So its example, it was in one competition, not on Kaggle, but there was additional quite large data set which was unlabeled and provided to as part of your training data. Do whatever you want. So in this case, I done prediction of different faults, different models, selected prediction like samples which model predict different way, different faults, different models predict differently, and I hand labeled this extra data set, very small one. I wouldn't be able to, it's video. It took ages to label, to watch them, and it's not very clear what animal on video. But in this case, even I could spend 10 times less time and have almost the same impact. You need to be careful with this approach not to introduce bias, because if you start to add in the same samples, you might change distribution train samples. So, but overall, it's very useful approach to manage how you spend your effort to have the biggest benefit of your training data. Okay, overall, how we're trying to do this split between faults. We want our validation fault to represent as close as possible how the model is going to be used. For competition, it's our private data set. For like real life project, it's how we expect data to be applied. We want our validation procedure exactly to, it's the main reason to validate how well our model would perform on unseen in this case, it also covers like time series. For example, if we don't expect to have the future samples, so we shouldn't input in our validations on the training set compared to validation fault. Sometimes this approach is not necessary. It's possible that samples are random. It's possible that everything we have for training will be used on the same area for validation. So we shouldn't try to do this every time. It's really worth to make sure that you understand your problem, you understand your data set, you apply what makes sense. It really worth to spend time initially for studying your samples, for do data exploration, and you don't always think about what may impact my label. It also what could be difference between this set and how its model will be applied in future. And quite common cases, it's if you train like maybe for voice recognition or face recognition, you want to make sure that the same person never comes to the training data set unless you expect model to work for this person, which is quite unrealistic. It could be place, so like cameras could be overfit with some samples, and you want to capture this. So you want always to understand what could be different for your validation, for your private leaderboard of when your data will be applied, and do the same split for faults. It could be different experiments. It could be multiple samples in the same experiments. You always want them to be on the same fault. But especially in competition, it's possible and very often case and like that metadata is stripped out. So what to do in this case? And one approach, one solution to this is to, and especially if external data is allowed, we can try to use similar set in similar domain and train model to separate those samples. And usually we use some activation from the some internal layer, or usually almost the last layer for clustering. Like one example, it was recent human protein classification. It wasn't very bad, but for almost everyone, the local validation was much more optimistic than Leaderboard. And it also was allowed to use external data, and everyone used because it was much bigger external data set, which was from the same domain, extremely useful, immediate boost to your Leaderboard position once you started training them. But this external data set actually has one more benefit, very important. What I noticed, it almost always was a couple of samples with sequential numbers, which are very similar. They're not the same, but what I found almost if the last number is sequential and everything else is the same, they look very similar, like those two samples and so on. So I trained another model with triple close to separate those two samples from the closest from the data set. So in this case, I have a model which can detect similar labels from the same experiment. I would suspect that could be taken a couple of times this Microsoft image from maybe some tissue or something like this. And I use this embeddings of this produced by this model for clustering. and it actually make validation procedure which match leaderboard almost exactly for this problem, and it also caused some improvement in our result, or at least I hope so. Okay, another example, it's on different platform. It was necessary to do classification of speakers by age group and gender, and also metadata strip. I tried to do random split to false, and if model overfit, it displayed like perfect 100% accuracy, and leaderboard is very bad. It's like 0.4, 0.3 F1 score. So what I have done, and it was also possible to use external data. So I download the huge external data set for Vox Celeb. It's identification of speakers. It's like 6,000 speakers, 1 million samples, audio samples, like much bigger data set than this one. And use model pre-trained on this data set for clustering. After this, I have very reliable validation scheme. So it didn't match exactly the leaderboard, but always improvement in the this validation on all 4 folds match improvement on leaderboard. And another benefit that pre-trained data on this huge data set, it also has significant improvement for this model performance. And I used this validation to select my hyperparameters, select different model architecture and so on. So this worked well. Okay, still, like, we're trying to make our validation scheme to match how we're going to use, or in case of competitions, we want to match distribution, or not distribution, we want to match difference between false to match training and the leaderboard on the private leaderboard. But we don't know a private leaderboard, and sometimes we can guess from just difference between our training and public leaderboard what could we expect overall from, like, how competition sponsor would like this model to be generalized. Sometimes another problem that we may know that could be different, but it could be so much different than anything within the training data set. How we can handle this, it's different problem. Another, like, happened once at least, it's possible that we know that could be different, and we know that it matched for both training data sets, probably the worst case. So I will explain those cases and what was my approaches to all of them. I still try to make as good as possible validation and try to use it for tuning my models, and use leaderboard only for validating that my approach is correct. And this is the same as with anything else. It really works to spend time to learn, to understand your set, your samples, you understand your problem. So it helps not only for building problems, it's also equally useful to build your validation procedure. Just you need to keep in mind how we want our model to generalize and build our validation based just from this goal. Yeah, one example, like there was competition to count sea lions on images from plane or from drone, I don't know. And the problem with this competition was that the distribution on public leaderboard was so like that on the public data set, it was so much different than trained data set. And it was very quickly discovered that if you scale the image like twice, we have much better score. But it probably doesn't help competition sponsor much. You don't want to rely on this stuff. So, and it wouldn't help just to use very heavy augmentation, because in this particular case, our labels are not scale invariant. We want to separate, not only count animals, but also separate age group and males, females. So if I try to scale images, I see a shift in my distribution of labels. It's expected because size is a very important feature. So I tried to do in this case, I spent some time to label the training data set, also to estimate the scale. So I extracted all the images of different categories of animals and tried to scale of them until they visually match. So I added labels not only for where the animal is, but overall what's the scale of this image, and train another model to estimate the scale. So I used very heavy augmentation. I created different scales, train model, and it's what I discovered as well. On this blue histogram, it's our training data set. Well, it's not very clean because it's still manual labeled, not perfectly, but you see the test data set, it has very different distribution, and it matches this twice time which was found by other teams. So I built my pipeline to create, to scale tests, to scale everything to the normalized image scale, and improve score a lot. Well, in this particular case, it wasn't necessary. What we found that private and public, they have the same distribution. So just applying your sample and your parameters tuned on Leaderboard, they were sufficient to win this. But potentially it's not useful result to sponsor. You want to make something which could be used and would be applied. It's not just win competition. Okay, so it's overall this approach. If I see some difference between train and some validation data, I'm trying to find how the difference, parameterize it so I don't fit to the leaderboard. I just try to estimate one parameter, maybe few parameters, just to make sure that I don't overfit the leaderboard. I still have some sensible procedure how to find parameters, how to, if necessary, to train second level models. Well, another quite interesting one that in the last data science ball, it was stated from the very start that the goal of this competition is to make model with generalized to unseen, very different distribution, completely different microscopy images. I don't know how well it would work in practice because it's very ambitious goal, and it's one of the sample of the test data which we had compared to the training samples. But in this case, the approach is to apply as much augmentation as you can. Very heavy, because we know that our actual samples would be very different. So we want to make sure that model can see like very, very different. And it was approach of the winning team to apply to have ensemble of the model with extremely heavy augmentations. Another approach which also helps realization is to make model to predict many different functions which are related to this, which in addition to have better post-processing, it also helps a bit with realization. It's also what we try to do is to find as much as possible of different diverse samples, hand annotate them and see and use them for both training and also to see how well model performs on them. And it was very clear that on new samples, at least without very heavy augmentation, it wasn't working at all. So we tried to add to find the level when potentially, in this case, your normal cross-validation would drop, but you see is that it just generalized better. And also one more sample when it was a bit unfortunate, but we knew that the distribution on private and public sets, they are the same and it's different from the train set. And it's not just sample, it's actually the annotation procedure was different, methodology. In this competition, it was necessary to predict different boxes when you think to match radiology predictions. And on the train data set, it was labeled by one person per sample. On the test data set, we want to be more careful, so with the given to 3 different radiologists, they labeled, and the result was intersection of 3 labels. So it's always smaller, and it's different than the train data set. And the matrix, unfortunately, was very sensitive to this. It intersection over union from 0.5 to 0.75. 75, it's very precise. So even difference between different people doing the same annotation would produce very noisy results. So what I try to do, I still try to create as good local validation scheme as I can. I try to train model, tune all the parameters as much as can using only local validation. Then I use this multiple models trained different faults. So it was single model trained on 4 faults to estimate what could be the difference, how hard this particular sample is. So if models predict slightly different results, that means most likely different people would have different results as well. So I shrank the prediction based on how different models predict different results. And the only parameter I try to tune on Leaderboard is extra scale, because it's still, those models are not as diverse as different people. I would expect people to have bigger difference between those 3 models. So I found how much I need to multiply my scale down to match the Leaderboard. So this actually worked. And it's usually the most interesting competition when the Leaderboard is different than your training samples, and it represents how model is expected to generalize. And even better if public Leaderboard, kind of similar distance but different. In this case, it's there is no point to overfit and to the Leaderboard position, especially if it's communicated by Kaggle. And so in this case, you know that Leaderboard is different, you know that private is different, and all you have to do is find model which generalizes. And it's also the most useful outcome for competition sponsors as well. So how, if possible, to achieve this, it would be the best. And again, it's useful not only competition, and especially not for competition. So with Kaggle, like, there is a lot of work behind before it reaches you. So the data is cleaned up, prepared. They're already split to train private and public. If you are doing work, you don't have this. You have to do this yourself. So if your validation is wrong, you don't see it. You don't have your public Leaderboard to show that your result is worse than just mean value over samples. You could deliver this model and it would just fail. It's also overall what I found, the machine learning pipeline would be hard to troubleshoot and debug. It's machine learning. It learns to work around your bugs and problems. You still have something performing maybe even reasonably well, but it would perform worse than it would work otherwise. And like without valid cross-validation procedure, you would never know this. So it's already hard task. It's better not to make it even harder. So it's well, it's more or less that's all from me. Well, thank you very much. If you have any questions, we'll be happy to answer. Hopefully it was useful.
Hey, can you hear me?
Oh.
The question is, and thanks a lot for the talk, it was very good. So, when you're at the end of a competition and you've thought about how all the differences between the test and the train, and you can only select 2 submissions, do you have any rule of thumb for picking those 2 based on everything you did?
Well, it's certainly I would select one which performed well on my validation set, and I would try to select 2 which are less correlated. Sometimes it's less clear because in competition you don't know distribution of the private, so it depends how I guess what would be different. In this case, it probably would depend on difference between your trained samples and public samples. So if I see them that they match what I expect them to match, I would certainly trust my validation. If I see that public is somehow different, then I would try to find a couple of samples which are diverse enough to cover as much area of possible solutions for the private as I can imagine. It's slightly different for competition and for real life in this case, because hopefully you have slightly, not always, but some kind of requirements an idea how you want your model, which direction would you modelize. Is public, sometimes it's hidden. Overall, yes, I would love to have this information from Kaggle as part of description competition, like what we want to achieve, what does it goal. Sometimes it's not always obvious.
Hello, over here. Hello. Can you hear me?
Yes.
Okay. So it's a very, very timely talk, and I really enjoyed it. So thank you for that. So I will just want to understand one part of your presentation. If you go back to the fish recognition, the species detection problem.
Right?
The one before that.
Okay.
So over here, right? So,
yes.
so I mean, this is a noisy data, and you mentioned that. So how did you do the clustering? Like how? I mean, what was the approach to do the clustering over here to understand that this is the image, part of the image where I have the fish, and I should discard the rest of the data? How did you do that?
Well, it was the second part of my pipeline, which I already used my validation faults to check that it works better than initial very naive version, just to use the full image. So for clustering, I just downsample and see that if I make very small, that sequential images will be almost the same. So I use them to group all together. But then the next stage would be, I don't really want everything else to be used for classification. I want model to see on the fish. So I had a couple of stages pipeline. First one, I used the detection framework like SSD to find the fish. Then I find angle, so I add extra labels and head and tail of fish, rotate it horizontally and crop everything except the fish. So I created another model which wouldn't see like any details like people around boats. For example, around shark, it's always the same person, large head. I don't know, but model most likely to cleanse this head, not the shark. And in this case, it's, from my experience, it's equally important what you exclude from input, not only which features you include. And I want some competition by carefully limiting what model would be able to use.
Thank you.
Thanks, great talk. When I look at the profile, Kaggle profile, I cannot, it's very good that you have very consistent results. Like in every competition, I don't know how many people looked at your profile, but I think you started 8 competitions. In all of them, you were like top 5. What's your secret to this consistency in the results? Do you attribute to some like way of thinking or something like this?
Well, at least I start early. I don't jump to competitions the last week or 2 weeks, so I have plenty of time to think. Like working full time, you need more time to allocate this. So this one I started like at start. I have 3 months. I make all the possible mistakes. I was learning this stuff, but well, I think the proper validation also helps. Well, in many cases, just team help. I cannot tell it's all my stuff, but yeah, it's hard to tell. It's you need to give you enough time to do competition, try different ideas. I have a make very good friends on Kaggle. I always have to team with them. So it's I can't tap into something else.
How many GPUs is necessary to win an image classification competition?
Well, it helps to have more of them. Like this one, I had like GPU, like not even a high-end one. It was my first competition. It was like NVIDIA, like with 4 gigs of RAMs, like mid-range one. Like now I have like 4 or 5, like 5 total. But yes, it helps to try different ideas, iterate faster. It's yes, it helps. You can do with 1 GPU or with just cloud. Just, if I have 4, I sometimes test for different ideas, and then I just train for faults for them. But yes, you don't need too much. It helps.
How do you pick competitions when you go in?
Well, so far on Kaggle, I tried to select one in new areas for me. So it's not always. Sometimes I just want to solve it. I just want to finished. I think was next one and so on. But I tried to do different like time series with sound, with image detection, segmentation, instance segmentation. Want structured data as well with Zillow. So I'm just curious to learn new stuff and understand something. Like Kaggle is the best, the fastest way to learn. So much faster than understands. It's because of me. Well, thank you very much. It was a pleasure.
Thank you very much. Guys, we're going